Welcome, students. Last class, we looked at interest problems, simple interest problems in particular. Today, we're going to look at mixture problems. This is another place where percentages come into word problems. And so what I want to do is I want to look at a basic example that involves solutions, so we can understand solutions. And then I'm going to have you go straight into the problem examples to get practice with those. So let's talk about solutions, and let's look at an example. A 50 milliliter solution of acid in water contains 42% acid. How much acid is in the solution? All right. So a solution is generally some sort of liquid that has part one ingredient, in this case acid, and then the rest of it is water. So we can make a really crude drawing of a glass, and this glass has solution in it, and in total we have 50 milliliters of that solution. And then of that solution, a portion of it, and in this case that portion is 42%, that portion represents the amount of the ingredient inside. So of course in the real world all of this would be mixed together, but if we could separate it, we would have this solution and 42% of it is some acid, and then the rest of it is water. So if we want to figure out how much acid there is in the solution, well, one thing we know is that the acid is 42% of the solution. So what we can do is we can use the percent equation here to figure out how much acid there is. We don't know how much acid there is, that's the unknown, so that's going to be the x. Is, we know, is equals, 42% is 0.42, of is multiplication, and then the amount of the solution in this case was 50 milliliters. So to figure out how much acid there is, we need to multiply 0.42 times 50, and when we do that, we end up with 21 milliliters. So how much acid is in the solution? 21 milliliters. But I want to point out this relationship here. This is really important. To figure out how much of the acid there was, how much of the ingredient there is, we need to multiply the concentration times the amount of the solution. So specifically, the solution times the concentration gives us the amount of the ingredient. In this case, the ingredient was acid, but in other cases, the ingredient might be something else. It might be chocolate, it might be oil, it might be something else. But the reason I write this out is because this is the relationship that we're going to be using when we're solving mixture problems. With interest problems, we had a different relationship. We knew that the principal times the rate gave us the interest. But in these mixture problems, it's going to be the solution times the concentration equals the ingredient. Okay? Now, I'm not going to go through any mixture problems in this video because I have linked you to a couple of videos that go through them, so you have a few examples. But before you do those, I just want to quickly walk you through what they're going to look like. With the interest problems, we had information about a person investing money in two different accounts, and we needed to figure out how much went in each account. In the mixture problems, you're going to have two different solutions that get mixed together to create a third, and you're going to need to figure out how much of each of the original solutions was mixed together. So it's a similar sort of a problem. Instead of 2 bank accounts, we're going to have 2 solutions that get mixed together. And you're going to be using this formula, solution times concentration equals ingredient, to organize your information and solve for the unknowns. Now I want you to click on the link below and go through these example videos one at a time to get comfortable solving solution problems, solving mixture problems.